grade. Are you ready for some more learning? I hope so, because here we go. We are back on our very last module, Module 7. So, some things you need to do before we get started. And if you need to pause this video, hit pause. Make sure you have your journal, your pencil, and you're ready to rock and roll. Okay, off we go. So let's just review real quick where we have been with our perimeter. We started Module 7 talking about our shapes, and we came up with all the different attributes of our shape. And one of our attributes was measuring the distance around the outside of the shape. That was our perimeter. So we can take our side lengths, add them up, and find that attribute. That was a measurement and data standard 4.8 because we were measuring the distance. And then we used our perimeter, our total perimeter, to find an unknown side length in our shape. So that was pretty darn awesome that we had figured out how to do a lot of different things with our shapes. Okay, so now we're gonna just take a little step back and add in area, which was our first measurement and data standard that we did in 3rd grade way back before Christmas. We covered measurement and data 3.5 through 3.7. And that took our rectangles and that found the total area covered by our rectangles. So we did a little bit of practice last week, kind of pulling that measurement and data 3.7, remembering how to multiply the side lengths to find that total area. So today what we're going to do is bring it all together. We are going out, we are leaving Module 7 with a bang. So if you look up here, I put a lot of standards. I couldn't even fit in the MAFS 3rd grade because I had so many standards. Today's work is going to cover perimeter, measurement and data 4.8. We're going to go back to area and really work that too. And we're going to pull in some addition, which is way back, our numbers base 10, 1.2 standard. And this is the biggest one we're really going to work on hard today, are word problems. Operations and algebraic thinking 4.8. That's a lot that we're going to cover. So take a deep breath and let's get ready to work. Okay. So this week we're going to focus on area and perimeter word problems. Sometimes the word problem will tell you this is area, find the area. Sometimes it will tell you find the perimeter. Sometimes you have to figure out what they're looking for. So I pulled 4 different examples from the lessons that we're going to work this week. Okay. Our first example is from one of our IXL.com problems. The IXL lesson is FF14. This is the easiest example, which is why we're going to start here first. Okay, so off we go. A rectangular goat pen is 10 meters long and 7 meters wide. A rectangular goat pen is 10 meters long and 7 meters wide. What is its area? So that is a pretty straightforward area problem. The most important things that we need to know is, first of all, we can go ahead and underline what they are giving us. What are our knowns? We know that we have a rectangular goat pen. We know it's 10 meters long, 7 meters wide. And then the second really important thing is, what are they asking us? So you have to go back and look. That's why we read these word problems at least 3 times. So I just jumped in and started underlining, but I want you, when you're working this out, read the word problem 3 times and really think. Make like a movie picture in your head. What are they asking me to do? See the model that you're going to draw, okay? So what they are asking us is, what is the area? Put a big circle around that because we really need to make sure we answer the question they're asking. Okay, we have a rectangular goat pen. It's 10 meters long and 7 meters wide. So I recommend we always start off with drawing our model. So I'm just going to draw my goat pen. I'm going to go 10 meters long. Whoops, well, I kind of did my 10 wide, but that's okay because we have the commutative property, so our 10 times 7 can go either way. Okay, and there we go. So we have 10 meters and 7 meters. So we covered both of our side lengths. And we know when we have area equals length times width. And I'll put an L and a W. So my area is going to equal 10 meters times 7 meters, which equals, well, that's an easy one. You got that, right? I'll let you figure that out. You got it. 7 times 1 is 7. We just add on that 0. We have 70 meters. Wonderful. Oh, look at me, Miss Shirley, making mistakes right out of the gate. I caught myself, so you can't catch me later. Square meters, because we're dealing with area. And when I looked up what that IXL answered, they gave me that right there, so I couldn't forget, okay? So that's a really straightforward area problem. They gave us 2 side lengths. To find the area, we multiply our side lengths. Our answer is 70 square meters, okay? All right, let's move on to the second question right here. The second question, I'm guessing will be a perimeter question. Let's see. Raj uses 6-inch square tiles to make a rectangle as shown below. What is the perimeter of the rectangle in inches? Okay, let's read that again. Raj uses 6-inch square tiles. That's important. He makes a rectangle. We can see the rectangle. They gave us the model, which is really great. We don't even have to draw it. What is the perimeter of the rectangle in inches? Okay, so I'm going to say, I have to ask myself, what am I looking for? I can go to my question. Let's go right to the direct question they're asking us. So this one is also pretty straightforward. They're asking us, what is the perimeter? Okay, cool. What do we know? Let's go back to the beginning. Raj uses 6-inch square tiles. Okay, so each one of his tiles, now we have a model here, and it's just like using those manipulatives we've used in class and putting them together, except there's one difference. You got it. Our manipulatives are 1-inch square tiles, but each is 6 inches. And they're asking me to put it all together and figure out what is the distance around this rectangle. So in order to find my perimeter, I need my side 1 plus my side 2 plus side 3 plus side 4. And then I find my total perimeter. Okay? So let's just see what we've got. We've got 6 inches from the beginning of that tile to the end of that tile. Okay? And then these are all squares. That's super important too. So every one of these squares is going to be 6 inches. So I'm going to have 6 plus 6 plus 6 plus 6 plus 6. Okay. Let's just skip count by 6s. Perfect. So I have 6, 12, 18, 24, 30. So this side is 30 inches. Great. And they told us they are squares. So what does that tell us about every tile? Every single tile is going to be 6 inches on its side. So we did this side. Perfect. And we got 30 inches. We'll go ahead and circle that. That's super important. Okay. So now let's figure out what is on this side. So I have 6, 6, and 6. I have 3 6s. 6 times 3 equals 6, 12, 18. That's right. 18 inches. Wonderful. Okay. So another important piece of information is that they told us this makes a rectangle. Okay. So let's just take that information and use it to help us out so we don't have to keep doing so much math. And I know when I have 18 inches on this side with a rectangle, this side is congruent, which means it's also going to be 18 inches. And then when I have this side is 30, I know this side is congruent, and that will also be 30 inches. Great. Now I have my 4 sides. Do I have everything I need to know about finding the perimeter of this shape? You betcha. So I just fill in my 30 plus my 18 plus my 30 plus my other 18. All right, off we go. I like to put those 30s together. That makes me happy. I'm going to see 30 plus 30 is 60, and then I'm going to put my 18 and my 18 together because I think that's just the easier way to do it. 18 and 18, so if I take my 18 and I add 18 more, I'm going to add the 10 first, that's 28, and then I can add 8 more to 28, 29, 30, 31, 32, 33, 34, 35, 36. I didn't even need to write anything down, I could just count. And then I know 60 plus 36, 60 plus 30 is 90. Add my 6, I have 96 inches, which is the perimeter of that shape. Most important thing, you just have to remember, you're looking for perimeter, so we're adding up the sides, okay? All right, let's take a deep breath. We got 2 more. You guys got this. I know you do. Okay, here we go. We have a counter in Cameron's kitchen, and it's 1 meter wide and 3 meters long. Good, we like those numbers. Our counter in Cameron's kitchen is 1 meter wide and 3 meters long. Cameron wants to replace the counter with a granite countertop. It would cost $178 per square meter. How much would the granite countertop cost? Okay, this is when we have to really, really think about it. They just didn't tell us what to do like they did in the other ones. So let's read it again. A counter in Cameron's kitchen is 1 meter wide and 3 meters long. He wants to replace the countertop, which would cost $178 per square meter. Square meter, super, super important detail. That's telling us that we are finding the area of that countertop. Awesome, I'm so glad we figured it out. Save us the trouble of worrying. How much would the granite countertop cost? Okay, so we want to know, let's circle our question. How much would his countertop cost? Okay, let's draw his countertop, okay? It says it is 3 meters long and 1 meter wide. Perfect. We'll say 3 meters, 1 meter, and 1 meter. Awesome. His countertop is 1 meter wide, 3 meters long, and he wants to replace it with, and it would cost $178 per square meter. So the first thing we need to say to ourselves is, how many square meters do we need? Square meters is area. We need to find the area of our countertop. Our area equals our length times our width, which equals 3 times 1, which equals 3 square meters. Perfect. Okay, now we're getting down to the nitty gritty. This is a real world problem. Sometimes we need to know what things cost. So we know that for every square meter, we have to spend $178, and we need 3 square meters. So we can either multiply 3 groups of 178, or we can just go ahead and add it up. So I say, let's pull out that numbers base 10 strategy that we were using and do a place value chart. And we're gonna put our hundreds, our tens, our HTO, and our ones. Remember, leave your space for when you have to carry over, okay? Leave some space here. We have to put $178 3 times because we have 3 square meters. So I'll put 178, 178, 178, okay. And I'm gonna add those all together. Okay, let's see what we got. So in our ones category, we have 3 8s, 8, 16, and 24. That's 4 ones, and we're gonna bring up those 2 10s and put them in the right category. Awesome. So we have 3 7s, 7, 14, 21, 22, 23, which gives me 3 10s, and we get 2 hundreds, and then we have 2, 3, 4, 5, 534. Don't forget the most important thing. They ask how much would it cost. This was in dollars, $534. We can put it in our answer box. Beautiful. That's the hardest kind of problem we're going to work on. That is a two-part word problem, OA 4.8. If we can do this, we can do just about anything. Very, very good. Okay, last one. The perimeter of Jillian's rectangular bedroom is 34 feet. The length of her bedroom is 9 feet. They broke this one down for us. This is from our Eureka Math, lesson 28. So when you get to this, you're gonna love it because it's pretty straightforward. They tell you what to do. It says estimate to draw Jillian's bedroom and label the side lengths. Wonderful. Okay, so she has a bedroom that's 9 feet long and 34 feet wide. So we're gonna go ahead. Most of our word problems when we're dealing with area and perimeter will be rectangles. Sometimes they won't, but they pretty much keep it this way because we're really only finding the area of rectangles. Sometimes the perimeter problems will get some other shapes. Okay, so we have 9 feet here and 34 feet here. Beautiful. Okay, so A says, draw Jillian's bedroom and label the side lengths. Check, we're gonna check that one off of our list. Okay, what is the width of Jillian's bedroom? Okay, the perimeter of Jillian's rectangular bedroom is 34 feet. Oh, look at me making mistakes again. 34 feet is not the width. The perimeter is 34 feet. Okay, so I need to find the width. How do I do that? Well, we go back to finding the unknown side length. I'm so glad that's why we have to read the problem 2-3 times. That way you don't make those kinds of mistakes, you catch yourself. Okay, so the perimeter of this bedroom is going to be, we know we have 9 feet, and that's a congruent side, 9 feet, and we have an unknown width. Okay, so we have 9 plus unknown plus 9 plus unknown, which equals the given 34. Beautiful. Okay, you guys have been really, really good about putting these two knowns together. 9 plus 9 is 18, plus our unknown equals 34. So I'm going to go over here and subtract my 18. Okay, I can't take 8 away from 4, so I'm going to unbundle that 10. And then this becomes 14 minus 8, which is 6. 2 minus 1 is 1. Okay, so now I have 16 feet. Is that my unknown? Absolutely not. Yes, thank you so much for figuring that out. That is not our unknown. Our unknown side length is this 16 split into 2 sides. So when I split 16 into half, what do I get for each side? You got it, 8 feet. Okay, so now I know the width of my bedroom is 8 feet. So what is the width of Jillian's bedroom? So where should we put that? We'll just put it right here. Our unknown equals 8 feet. I like to box my answers. There we go, very clear. Okay, so now they're asking us to continue to solve. What is the area of Jillian's bedroom? Well, we have our length and our width now, so that's easy. We're back to just straight length times width. So my area is my length, 9 feet, times my width. Now we know it's 8 feet. 9 times 8 equals 72. You got it. Feet, right? Got me again. Area is always in square feet. Perfect. Look how easy this is when we take it one step at a time. Okay, last part. Jillian has a 4 foot by 6 foot, that's important, rug in her room. What is the area of the floor that's not covered by the rug? Okay, we want to know what area is not covered by the rug. So we have to figure out what does the rug cover first. So the rug area equals, and it's 4 feet by 6 feet. 4 feet by 6 feet, which equals 24 square feet. Okay, good. That's our rug. Now we know the whole bedroom is 72 square feet. So yes, we find the difference. We always find the difference with subtraction. Beautiful. So we have our total, 72 square feet minus 24 square feet. And we go ahead and then we will find the area that her rug did not cover. Okay, so can I take away 4 from 2? No way, no how. Go ahead and unbundle, cross that 7 out, it becomes a 6. My 2 becomes a 12. 12 minus 4 is 8. 6 minus 2 is 4. So how many, should I say this is 48 feet not covered by that rug? Nope, we're still talking about area. So it's 48 square feet. Perfect, not covered. Just make sure we know what we're talking about. Okay, so boy, there's a whole nother standard, our numbers-based 10 subtraction standard that I didn't even put on our list. So we covered a ton of standards. Work hard this week. If you can do each one of these problems, taking it step by step and just really, really reading the word problem 3 times, underlining the important information, circling the question they're asking you, you will be good to go. You have all the tools you need. Take your time, show your work, okay? All right, go get them.